Hello everyone! This will be the first in a series of videos about parabolas. So the first video about the first paragraph is appropriately called parabolas. We will first have a look at some jargon or terminology for parabolas. Then we will specifically look at upward or downward opening parabolas, and lastly we will look at how that works when the function has brackets. So let's start with some terminology. First off, it will come to no surprise that this is a parabola. And specifically, this is an upward opening parabola, because the opening, it opens up to the top. Well, if there's upward opening parabolas, that implies the existence of a downward opening parabola. And, well, that would look like this, opening up downwards. So later on in this video, we will be talking more about that, about those upward and downward opening parabolas. Enough about types of parabolas, there's also parts of parabolas that have names. For instance, an important point on your parabola is the vertex. It's the highest in a downward opening parabola or the lowest in an upward opening parabola, highest or lowest point. And lastly, through that vertex, we have an axis of symmetry. The line going straight up, down, whatever, through the vertex. And this really is an axis of symmetry in the symmetry definition. Because if I would put a mirror on this line, I would still see the full parabola. This point is just as far from the axis of symmetry as the opposite point is, and that goes for anywhere on my parabola. And the same for the other parabola, and in fact for any parabola. So enough about the jargon, enough about the terminology. Let's have a look at upward or downward opening parabolas. Specifically, how can we determine that from the formula? So the formulas for these two are written here. And I'll start by just stating how you can see it, because it is really straightforward. An upward opening parabola happens when x squared is positive, and a downward opening parabola happens when x squared is negative. So in f of x, we've got 0.5 x squared. 0.5 is positive, so f of x has an upward opening parabola as its graph. Conversely, g of x has minus 2 x squared. Minus 2 is negative, so the graph for g of x is a downward opening parabola. Now I would like to go a little bit into the why of this. This is entirely optional, so if you think it will just confuse you, then you are free to skip this and go to the next section. I just feel that for some people this may help them remember which one is which, and to get a bit of an intuition of what is going on. So what is happening is that in any of these functions with like powers of x, the highest power has the most influence on the shape. Because 10 squared is going to do more in your function than just 10 is, and even more if you'd have higher powers. And clearly x squared is the highest power we have here. So x squared is going to determine the main shape. So ignoring everything else that's going on, all the x and all the numbers that's added and multiplied, let's just have a look at what x squared and minus x squared do. Starting from the vertex. So x squared and minus x squared have their vertex at 0, 0. And then if I fill in minus 1 or 1, minus 1 squared, doesn't matter, it's going to be 1. But then for minus x squared, we first do 1 squared or minus 1 squared, and then we add that minus, so we get minus 1. Same happens for 2 and minus 2. X squared, 2 squared, minus 2 squared is both 4. But then for minus x squared, we still add that minus and we get minus 4. So for x squared, we're going to have that 4, that 1, that 0, 1, and 4. And we're going to have an upward opening parabola, roughly drawn. Whereas for minus x squared, we've got that minus 4, minus 1, 0, minus 1, minus 4, minus 9 afterwards. and we have a downward opening parabola. And no matter what we add to it, what we multiply it by afterwards, it's going to move around a bit maybe, change its shape a bit, but it's going to stay that same upward or downward opening parabola. So that is just to give you an intuition, not a very exact explanation, but some intuitive idea of why this happens. Again, if this just confuses you, feel free to erase this from your memory and not think about it again. This part is the important bits. But if this helps you understand what's happening, feel free to use it. Okay, but what if we get some very specific function and it has some brackets? Then maybe it does something weird. For instance, this one, there's this minus there at the start, so clearly it's going to be downward opening, right? And then you plot it and nope, it is upward opening. So unfortunately, brackets can really hide what's going on with our function. So what we're going to have to do is we're going to have to get rid of the brackets here. And this specific function has three parts for the brackets. We have the minus, we have the x plus 1, and we have the 3 minus x. And we can only solve them two at a time, but which order you do doesn't really matter. You can solve the minus x plus 1 first, and then the 3 minus x. I'm going to first solve the double brackets, and then we'll figure out the minus. If you'd rather use a different order, you're free to do so. You can pause the video to double check that it indeed will give the same answer, or just follow along. So I'm going to solve the brackets here. I'm going to do x times 3, x times minus x, 1 times 3, and 1 times minus x. So I get, well, we still have that minus, we haven't done anything with it yet. But then we get 3 times x, 3x, we've got minus x squared, 1 times 3 is 3, and 1 times minus x is minus x. Let's clean this up a bit. This 3x and this minus x becomes 2x, and we shuffle the order, because we like to have it in the order of the power, so x squared, then x, then number. And then we figure out this remaining minus. So minus times minus x squared, minus 1 times minus x squared. We add the minus here and over there. So minus minus x squared becomes x squared, minus 2x and minus 3. And here we see that indeed x squared is positive, so it makes sense that it was indeed an upward opening parabola. That was all I needed to say for now about parabolas. I hope this helped you figure out whether the graph of a function is an upward or downward opening parabola and reminded you of some of the terminology.